Hello everyone, my name is Rihani. I am a PhD candidate and a member of the cover research team at the University of Liverpool School of Architecture. My research area is investigating the potential of digital tools and immersive technologies, AR and VR, and their role in creating and recreating 3D cultural heritage environments and experiences. My research aims to relink tangible and intangible heritage within comprehensive, immersive, interactive virtual experiences that enable enhanced visitor perceptions and experiences in different cultural heritage sites in the Middle East. This region is an ancient cradle of many civilizations that has witnessed numerous traumatic conflicts and upheavals that have caused tragic damage to many heritage sites, as well as human lives. The title of my presentation is 3D Photogrammetric Reconstruction of Al-Khasneh, the Treasury, utilizing crowdsourced images and retracing visitors' experiences in the ancient city of Petra, Jordan. The aim of this presentation is to investigate the role of crowdsourced images of visitors' experiences and the influence of digital photography on the 3D virtual reconstruction of cultural heritage monuments in the age of mass image production through digital cameras and smartphones. Also, this presentation examines the importance of employing off-shelf cameras and handheld capturing devices to create high-quality 3D models of cultural heritage monuments through retracing visitors' footsteps in the main trail of the ancient city of Petra in Jordan. The Holy Land has captivated visitors for centuries, and Jordan has innumerable archaeological sites. The Middle East in general is brimming with cultural heritage sites and breathtaking and mysterious relics of the past. It has been home to some of mankind's earliest settlements and villages, and many of the world's great civilizations can still be seen today. The ancient city of Petra is carved into the massive red mountains that surround it, and it's one of the great wonders of the world. This UNESCO World Heritage Site is among the world's most famous archaeological sites for its combination of ancient Eastern traditions and Hellenistic architecture. Visitors will not want to miss the Al-Khasneh, the city's most elaborate temple, carved out of a sandstone rock. The city of carved facades, monuments, tombs, and temples became known around the world with its special appearance in Indiana Jones and the Last Crusade in 1989. Today, more than ever before, the world is losing its architectural and archaeological cultural heritage icons faster than they can be recorded and documented. It's crucial that we attempt to document and preserve all of these treasures, lest they be lost to us forever. As UNESCO recently declared that many cultural heritage sites in the Middle East are facing different and various considerable threats due to different reasons. World Heritage Sites have suffered considerable and sometimes irreversible damage. Many of them are being used for military purposes or have been transformed into battlefields, such as many locations in Syria and Iraq. Archaeological sites are being systematically looted, and the illicit trafficking of cultural objects has reached unprecedented levels. There are alarming reports that the cultural heritage in the Middle East has been deliberately targeted for political and ideological reasons. To define the problem, we can see that our cultural heritage sites in the Middle East are still under continuous threat. In the current situation, many of these sites are either partially or completely destroyed, and most of them, unfortunately, still have not been documented. Due to the high cost of documentation, a lack of documentation skills, and the large scale of these sites. Moreover, some of these sites are still inaccessible due to ongoing armed conflicts. However, as a proposed solution, the growth of the Internet and broadband services has provided access to an uncountable number of images, which were captured, uploaded, and disseminated by different people around the world. These photos provide a vibrant source of material to be used in the future, recording these monuments through different periods. These resources in general are freely accessible, available anytime, everywhere, and are continuously updated. The increasing significance of smartphones and their continuous technological development, especially improved camera performance, has enhanced image quality for the best result possible. Photogrammetry and image-based reconstruction technology employ several photos with a good amount of overlap to create 3D digital replicas. Recently, numerous free, open source, and easy-to-learn software packages have emerged to support this technological application. All these factors together make the crowdsourcing method of reconstructing cultural heritage sites efficient, possible, and promising for the future. The last 20 years have observed a revolution in the technology of creating 3D models and digital replicas. As many artifacts, monuments, and cultural heritage sites have been reconstructed and transformed into different digital formats. The importance of cultural heritage virtual reconstruction is to protect, preserve, and interpret culture and history, and to bring back some elements from the past to our real-time life. The increased use of 3D imaging and remote sensor devices has gained attention from academics and professionals in the field of cultural heritage documentation and visualization. The word photogrammetry is a combination of three terms: photo meaning light, gram meaning drawing, and metry referring to measurement. Therefore, photogrammetry is the science of making measurements from photographs. Structure from motion is the process of reconstructing 3D structures from its projections into a series of images. It signifies the estimating of 3D geometry based on different camera positions. The input is a set of overlapping photographs for the same object taken from different viewpoints. The output is a 3D reconstruction of the object. The recent proliferation of open-source, free and professional photogrammetric reconstruction software packages has increased choices for users, enabling them to choose the most suitable software that guarantees the best results possible for particular applications. Some of this software can be easily downloaded and installed on PCs with no need for robust computer requirements. Meanwhile, the power of the local device should not be a problem for performance anymore. In some applications, such as Recap from Autodesk, the whole process can be done on the cloud or virtual computer. Mainly, these applications provide an automatic reconstruction tool that simply takes a folder of input images and produces a sparse and dense reconstruction in a workspace folder. Digital technology has offered the possibility to edit the 3D generated meshes, fixing incompleted geometries and removing the unwanted parts. Consequently, digital tools have facilitated the process of creating complete 3D virtual environments for any archaeological site, which can be used later to develop new types of virtual museums and experiences. Creating virtual environments is no longer very complicated, as the new technology of image-based modeling can create these environments from multiple images from various sources. It has also become possible for the user to walk around and to experience these 3D synthetic environments by using immersive technology applications such as VR systems. For instance, a snapshot 3D virtual environment has been created for the Cardo Maximus of Jorosh in Jordan using a smartphone camera and 3D photogrammetric reconstruction software. The archaeological park of Petra was selected in this research due to its importance and historical value. The site is more than 2,000 years old, and it's one of the most iconic instances of cultural heritage in the world. The diversity of monuments in this city is remarkable, including tombs, temples, paths, and dwellings carved into hard rosary sandstone. This cultural heritage site has traditionally been one of the most visited sites, not only in Jordan, but also in the whole Middle East, making the probability of finding crowdsourced images extremely encouraging. The ubiquitous adoption of smartphones and their ever-improving photographic and general quality mean that visitors to heritage sites generate reams of high-quality content that can be utilized in 3D reconstructions, galvanized by easy sharing in social media sites via broadband internet connectivity. As a result, all these drives have supported the use of crowdsourced materials in this study as a source for digitizing Petra monuments based on using public imagery. In this study, the main ambition is investigating the possibility of creating 3D digital replicas for different monuments in Petra city by using visitors' photos collected from their cameras. Social media platforms were the primary source of gathering the raw materials of the crowdsourcing method. And the main materials are photos taken by visitors during their experiences in the real physical site of Petra. The physical experience is essential in the methodology, since it shows the route that the visitor took in exploring the city of Petra and the visual access between the visitor and monuments. We can benefit from using crowdsourced material in virtual reconstruction, as this method provides an excellent solution in the case of restricted human mobility and limited cultural heritage site accessibility. For instance, in the current time that we live now, this technology could be the perfect solution to create highly detailed 3D models for any monument without going physically to any heritage site. We can incorporate previous visitors' experiences already translated and depicted in photos from different people with different views and different experiences of such sites. Walking in Petra is a central part of the experience for visitors to enjoy and appreciate the monuments of the city, as I have experienced personally during my previous visits. Many visitors prefer to explore the site on foot, specifically in order to take more photos as well as to enjoy the site spatially. Using vehicles is forbidden, and visitors have two options to explore the site, either walking or riding a camel, horse, or donkey. Walking is more flexible and makes it easier to take photos. Several trails are maintained by the local people, enabling visitors to explore Petra and organizing visitor movements. This is important to protect visitors from losing their way, as the heritage site is massive, with manifold routes, traversing an area of around 70 square kilometers. Also, these routes are designed to offer visitors a meaningful experience by viewing the largest number of monuments, and in each trail, there are specific monuments with different views, resulting in different photos. According to the Jordanian Ministry of Tourism and Antiquities, there are 7 official trails in Petra to be used for touristic purposes. The main trail is the dotted orange line on the Petra map. It starts at the visitor center and ends where the Abdare trail starts. It's a smooth, flat, well-marked trail. The main trail is the only trail into the park, so this is the main gateway into Petra for visitors, and consequently it's the most visited trail. It heads from visitor center to the Obelisk Tom through Al-Sik to Al-Khasneh, the Nabatean Theatre, the Street of Facade, the Royal Tombs, the Colonnaded Street, and finally Abdare, or the monastery. Covering an overall distance of around 4 kilometers, it takes approximately between 5 to 6 hours to walk. This trail is preferred for most visitors due to its flatness. It has a mainly horizontal trajectory with minimal vertical circulation, especially in the first part. It's thus very safe and its sidewalks are well marked. As I mentioned previously, this trail is the main gateway to the city center and the well-known landmark of Al-Khasneh, the Treasury. It gives visitors the opportunity to view more than 8 monuments in a relatively short distance. It's the most visitor-friendly route in the entire city of Petra. For this reason, we will find most of the images in social media and search engines have been taken on this trail. For the reconstruction of Petra monuments, one image source had been used: public domain touristic or crowdsourced photos collected from web search engines and different social media platforms. Most of the images were downloaded from Flickr, Facebook, and Twitter. The search was carried out looking for tags in many different languages, which might indicate the place and function of the monuments. Google image search was particularly useful, especially its reverse image search similarity tool, which yielded a number of untagged photos. After filtering the images, excluding those without EXIF data and those with small dimensions in order to increase the accuracy, a total of 770 suitable visitors' images remained. The minimum image size used was 1200 by 1600 pixels. I retraced the movement of an imaginary visitor inside the main trail of Petra to observe the monuments that would face inside the real physical experience. Firstly, the Obelisk Tom should be the first monument that the visitor would see on the left side of the trail, as the figure shows. The set of 57 images was imported into Agisoft Metashift software to start the 3D virtual reconstruction process. We can see from the photos alignment step that the majority of collected images were captured from some common viewpoints, mainly during the outbound trip, when visitors were on their way from the visitor center to Al-Khasneh. On the other side, a limited number of images were found on social media for the Obelisk Tom from the return trip. As expected, the 3D dense point cloud model was not that perfect due to the lack of images that would ideally cover this part of the monument, as illustrated in the figure showing the 3D mesh with some black holes from the side of the return trip. I think the reason behind the dearth of images from the return trip is that they were perhaps somewhat fatigued, while on the outbound trip they were still fresh and passionate to take more photos. Furthermore, this monument is the first major feature on the trail. From the initial results of 3D photogrammetric models, we can see that these models were affected greatly by the visitor experience and the direction of visitor movement on the main trail. Al-Silt is a rock canal that measures 1.3 kilometers in length, 3 to 12 meters in width, reaching up to 90 meters in height. The main part of this gorge is created by natural rock formation, and the rest was carved by the Nabateans. Creating a 3D model of this passage using crowdsourced material is almost impossible, since the natural form of the walls and the length of this passage provide big challenges to building a comprehensive photographic model. The Treasury, or Al-Khasneh in Arabic, presents a significant attraction point for many visitors around the world. Thousands of images have been found on social media for this monument, but only 175 images were chosen for the 3D reconstruction after filtration. A reconstruction methodology was developed for creating a 3D photogrammetric model for this key monument by using crowdsourced materials. The process was carried out through three main phases, as the pipeline shows. Firstly, the pre-processing phase includes collecting crowdsourced materials and data. Secondly, the processing phase contains the process of 3D photogrammetric reconstruction using Metashape software. This phase mainly comprises 5 main sequential steps: align photos and camera calibrations, build a sparse point cloud by structure from motion algorithms, build a dense cloud by multi-view stereo algorithms, create the main mesh, and finally generate texture. The initial 3D texture model usually contains some problems. Therefore, in the third phase, post-processing, the 3D texture model can be cleaned from the unwanted parts, edited, refined, and optimized. The following figures illustrate the process of reconstructing Al-Khasneh using 3D photogrammetric reconstruction. Firstly, the pre-processing phase, by collecting the required photos and the filtration process. Secondly, the processing phase, by aligning visitors' photos and camera's calibration to create sparse point clouds, which are then densified using multi-view stereo algorithms. The initial 3D dense point cloud model shows some limitations in generating the whole mesh, as we can see some holes in the structure, especially in the upper areas, and some hidden inner corners behind the columns. This is obvious from the massive scale of the monument. as visitors' photos have shown some limitations of capturing and displaying these parts. The photos alignment phase revealed that visitors took the majority of collected images during their walk onto the main trail. These images were captured from common terrestrial visual points, mainly located on the ground level of the monument. Although the overlapping between collected images was high, as it covered more than 80% of the whole monument, the set of 175 images was not sufficient to cover the unreachable parts. The generated 3D model was imported to Mesh Mixer software to evaluate the condition of the generated mesh and the missing parts. The inspector tool as an automated investigator for checking the holes and fixing the missing parts of the 3D mesh. Actually, the initial inspection showed that the 3D model was partially affected by the missing photos, especially those areas that were invisible for visitors during their experience. To solve this problem, I found on social media a team of Jordanian hikers who run occasional hiking trips and adventures to specific places in Petra, such as the place of high sacrifice, Wadi Farasa, al-Bayyara, and less commonly visited trails leading to two magical viewpoint areas opposite to the Treasury. This team is led by an indigenous person whose family live in Petra. The first viewpoint is above the royal tombs. The visitor must climb more than 500 stone steps to reach the top of this area, which is a demanding physical task. Thus, few visitors venture there due to its arduous nature, as well as safety concerns among site managers. The second viewpoint is located somewhere behind Wadi al-Farasa, particularly on the way to the high place of sacrifice. This path is also still unfamiliar for many visitors because of safety reasons. It can take more than 2 hours, during which the visitor ascends to the top of a high place to enjoy another spectacular view looking at the Treasury. This hiking group offered this study a set of 35 additional photos captured from both viewpoints. The new collection has offered this study very beneficial visual material to cover the upper hidden areas of the Treasury. Therefore, this monument could not have been entirely reconstructed without these images. Consequently, the experiment was reconducted by inserting the previous set of 175 images with the 35 newly added images to fix the problems of the first model. In this figure, we can see the difference of photos, alignment, distribution between the initial model and the final model after adding the 35 new photos. The dense point cloud and the X-ray 3D model here show the missing areas that exist in the first model, which have been covered and reconstructed by the 35 newly added images. The last phase in the process comprises editing the minor missing meshes, filling holes, refining, and mesh optimization. The following shots show the final results of the Treasury 3D model after mapping the 2D texture image on the 3D mesh using UV mapping method. The pipeline here illustrates the process after combining the original 175 images with the 35 newly added images. The same process of reconstruction was applied over different monuments in the Petra using the crowdsourced method of reconstruction based on visitors' photos taken throughout the heritage site. All of these 3D models were modeled by retracing visitors' movement within the heritage site of Petra, in particular the main trail. These images were collected from different visitors who had no idea their photos would be used in helping reconstruct and preserve Petra. The images were taken at different times during different experiences found on social media platforms and image searches. Then they were reconstructed photogrammetrically using structure from motion and multi-view stereo algorithms. Digital media is beginning to offer new technological solutions to preserve and represent cultural heritage assets. This study highlights the role of the public in digitizing and documenting cultural heritage sites and valuable monuments through their memories and visits, particularly in the current era, when many historical sites in the Middle East are inaccessible due to wars and regional clashes, aside from the global COVID-19 pandemic. Therefore, using this technology in the cultural heritage preservation domain is changing the role of regular visitor from being an observer to being an archivist and conservationist, generating and publishing documentation to preserve the imagery of these sites, particularly the most valuable structures. The reconstructed digital replicas can be used efficiently for developing entire 3D virtual environments and experiences, whereby the user can get the opportunity to travel virtually and explore several heritage sites without facing the barriers of the physical world. These environments are flexible enough to accommodate digital humans or personal virtual assistant that can tell stories about these structures and some hidden stories regarding our threatened intangible heritage within one unified interactive virtual experience. In conclusion, I hope to demonstrate how my research can find applications in other cultural heritage sites around the world and offer new methods, for instance, in the reconstruction of lost cultural heritage sites. Also, hopefully, this research can offer such a practical and useful workflow for other researchers in digitizing cultural heritage monuments by using 3D photogrammetric reconstruction based on using crowdsourced materials and retracing visitors' movements and physical experiences within different cultural heritage sites. Thank you.